Hello, this is Paul Reynolds, and I'd like to share with you some information about advanced glycation in products or ages and sugar. So here is a picture of glucose. And to set the stage, glycation is the non-enzymatic glycosylation of proteins, lipids, or nucleic acids, and that glycation is mediated by a sugar. Ages accumulate in lots of different settings, including hyperglycemia, aging, inflammation, renal failure, and even oxidative stress. So if we pick up here, this is an image of glucose, and this glucose molecule regularly rearranges into this linear sugar molecule, which in the presence of a protein attacks this N-terminal region, or the amino group of this protein molecule. This entity then goes through a Maillard reaction, which causes a transient formation of what's known as a Schiff base. This is highly unstable. However, very quickly this will rearrange via an Amadori base to form this more stabilized sugar, which, when oxidized, will accumulate ages. These little triangles here. These are irreversibly non-enzymatically generated, and they attach onto a host of different proteins. Now, ages will bind to the receptors for advanced glycation in products. And age-rage binding causes cell signaling that culminates in the activity of NF-kappa B. That is a potent pro-inflammatory activator of gene expression. Now, rage activation, just like this, is a hallmark of lots of diseases like diabetes, neurodegenerative disorders, cardiovascular disease, atherosclerosis, and even cancer. And as you can see here, activation within the nucleus leads to the elaboration of inflammatory molecules. Now, ages and rage are present throughout the body, so many tissue types, including, although not shown here, muscle and fat would be sources for age formation. Let me lastly navigate this wheel of ideas related to lipid metabolism, hyperglycemia control, inflammation, and antioxidation. So let me first highlight this in the upper left, lipid metabolism. Whereas allulose inhibits fatty acid synthase, or FAS, ages can increase the activity of this enzyme, leading to much more fat accrual. While allulose enhances hormone-sensitive lipase, or HSL, ages will decrease the activity of HSL, which is a fat-burning hormone. We also know that ages differentially regulate PPAR enzymes. PPAR alpha leads to energy dissipation, and it does that by promoting fatty acid oxidation, whereas PPAR gamma favors energy storage, mainly through increased lipogenesis. Moving over to the upper right, let's talk about the sugar or hyperglycemia control story. We know that allulose inhibits glucose synthesis, elaboration, and uptake, whereas allulose inhibits intestinal sucrase, that's the enzyme that breaks sucrose into glucose and fructose. Ages will increase the activity of that enzyme. Allulose increases the activity of GLP-1, which is a very strong hormone that decreases appetite and lowers blood sugar levels. GLP-1, interestingly, will reduce the expression of RAGE, the receptor for ages. Therefore, it indirectly reduces age-related pathologies like inflammation and oxidative stress. So lastly, let's talk about that story at the bottom here, inflammation-wise. Whereas allulose reduces the elaboration of many inflammatory mediators, 3 of which are shown here, ages exacerbate inflammatory signaling and will lead to the release of these inflammatory cytokines. In fact, scores of cytokines are increased following age-rage interaction. While allulose increases antioxidant enzymes like superoxide dismutase, simply exposing SOD to glucose leads to the glycation of that enzyme. SOD has ages attached to it, and therefore it decreases its antioxidant activity. So that's a quick summary But essentially, you can boil it down to the following 2 points. Glucose and fructose enhance age formation, and allulose will decrease age formation. Thank you very much.